Very easy thing. How do we compute the equilibria of a model? So we are going to talk about equilibria. I think that you already have the intuition, some prerequisites. I'm pretty sure that you know those prerequisites. Exercises for you for the next time. We have to be able to compute the equilibria. What is an equilibrium? This one is an equilibrium, true? And if we take hail that is falling down, the single particle of hail, is it in equilibrium? Not whenever it's traveling, true, because it's moving. What is an equilibrium? An equilibrium is this. Where will the equilibria be? At which temperature will we have an object in equilibrium? This is a small brick in a very large room whose temperature is 20 degrees. If we start with the brick that is 100 degrees, where will it go? It will go to 20, true? If it starts at minus 10, it will go to 20. If it starts at 20, the derivative is going to be 0, true? What is the equilibrium of the system? In this case, y dot is equal to 0 means t equals to 20, true? When is this one in equilibrium? Whenever the angular velocity and the angular position, the angular velocity and the wheel velocity. So there's two angular velocities. There's the angular velocity of the body and the angular velocity of the wheel. True. Those ones have to be 0, and the accelerations have to be 0. True. Position might be whatever. True. This one, here is in equilibrium. True. Here is in equilibrium. True. Not too much, but you got the point. You might have an infinite equilibria. For example, whenever you've got a ball somewhere that is standing somewhere on a plane, you will have a lot of equilibria. But equilibrium means acceleration, velocity, all the stuff, the derivatives equal to 0. Okay? That means that from a phase portrait point of view, we are going to discuss about phase portraits very soon. You need to have trajectories that are constant. Straight lines as a trajectory. Got the point. Got the point. Where are the equilibria here? Do you see equilibria here? Do you see points when you have y dot equal to 0? One. There's one that is around minus 1.8 something. This one. True? This one. It's an equilibrium. You have an intuition of stability, true? Something that is stable or unstable. This one. Is it an equilibrium that is stable or unstable? This is an equilibrium, but it's unstable, true? In the sense that if you move slightly away, you escape. And this one is stable because you go back, true? We're going to see much better definitions, but this one, would you say that it's stable or unstable? Why? Discuss. Why would you say that it's unstable, that it's correct? Unstable means that I move a little bit far and I will escape. Indeed. Excellent. What is happening here, people? If I start here, I will go in this direction, true? If I start here, I will go in this direction, so I do not go back to the equilibrium. Now, there was a question that is an excellent question. Very, very nice question. I was saying the hail, the single particle, the single stone, I do not know the name, technical name. Do we think it's an equilibrium while it's traveling? Depends on what you consider. If I consider the velocity and it reaches terminal velocity, there's an equilibrium for the velocity. But it means that I'm kind of disregarding position, okay? So I have an equation that in a certain sense where position doesn't matter and I don't care. And it's something that might happen. If you think at a motor, a servo motors, servo motors, for who the people do not know the term, is a motor where you have a mechanism for controlling either position or velocity or both. And you might ignore, if I've got a propeller that is propelling the boat, I care about the velocity of the propeller, the angular velocity of the propeller, not how many turns did through. In that case, you might have an equilibrium for the velocity, but of course you will not have an equilibrium for the angle. True? You see the point? So, depending on what is the meaning to variables that you are putting something dot, the equilibria is the dots have to be zero. What do you model? Depends on what you need to do. If I need to control the velocity of the boat, the speed of the boat, I don't care about the angular position of the propellers. Are we together? Are there questions?
One question about the equilibrium. When we define the equilibrium for this order, we were talking about the equilibrium of the order or of the function of y dot or of y.
Equilibrium of the model, that is the ODE.
Okay.
So whenever we take an ODE, this equals to f of yu is this and this such that this is equal to 0. So we talk about the equilibrium of the model. And then sometimes we are a little bit sloppy and we say the equilibria of the system, saying that the system is the model. It's not correct, true. Whenever we compute the equilibria, we compute the equilibrium on the F. Is the F the system? It's the model of the system. But sometimes we say, okay, it's a sufficiently accurate representation of the system. So we do this confusion. But you see that from a terminological point of view, it's the equilibrium of the model. Okay? Are we together, people? We see each other on Tuesday? You've got quite some stuff to read and to check. True? People, important, several questions are new questions, and there might be written not in a good way. Let me know. Question 17. And by the next time, also, there's 2 persons that signed up for the reference group. At least other 2 persons for the reference group. Okay? Please.
As well, because when you define, you said it define